In this video, I'll talk about the research process. Here are some characteristics of research. Research is systematic, so it's carefully and deliberately planned. That's in contrast to some of the ways that we gain insight that I talked about in the previous video, such as intuition, trial and error, tradition, authority. Research, unlike those, is carefully planned, systematic. Research is logical, so it uses the forms of logical reasoning that I spoke about in the previous video, inductive and deductive reasoning, to create hypotheses and to interpret research findings. Research is empirical, meaning that it relies on observed data, and research is replicable, which means that it can be repeated to verify or challenge the results of previous studies. All these characteristics imply that research involves a step-by-step process, and that's known as the scientific method. When you read about the scientific method in different textbooks or different articles, they all tend to use slightly different terminology to convey the different steps in the scientific method, but it all kind of ends up being the same. I just wanted to give you a couple different examples of the steps of the scientific method. So according to Isaac and Hubert, who are specifically talking about how this looks for graduate student research, they dedicate a lot of space in their diagram to coming up with your initial idea. So it starts with acquiring a bunch of facts that you then use creativity to combine in interesting ways to come up with new ideas for your thesis. You put those ideas through a critical thinking filter, basically through peers or yourself or your professors, to tell you, look, like these ideas aren't as good, go with this great idea that will then be the basis for your thesis project. You use that idea to come up with hypotheses that you then base a study off of. So you collect data, you analyze data, you interpret patterns, and those findings contribute new knowledge to scientific understanding. So that's just one example. A couple other examples. Thomas and Nelson, 1990, it starts with a problem. You do a review of literature. You use logical reasoning to come up with testable hypotheses. You use that to design a study that includes subjects, measurements, procedures, and a design. And you basically use those methods to collect data and analyze that data, which leads to findings, which leads to something that you can discuss with other people in your field. And another example from Isaac and Hubert, this is kind of more like a flow diagram of the whole process. So it starts with a topic and a scoping statement. Then you basically come up with a research plan, which may undergo a couple rounds of revision. Once it's ready, you use that plan to do your data collection, data analysis, and you basically, once you have enough data, once you've analyzed enough data, you have some findings to report, your research plan is complete. So again, 3 different examples kind of all showing the same steps, just with slightly different terminology. Similarly, if you look up a dictionary definition of the scientific method, each source is going to give you a slightly different wording. So I just chose one. They're all basically the same. Dictionary.com says that the scientific method is a method of research in which a problem is identified, relevant data are gathered, a hypothesis is formulated from these data, and the hypothesis is empirically tested. So now I've used the word hypothesis a couple times. I should probably tell you what that actually is. A hypothesis is an expected result. How do you come up with a hypothesis? Well, you can base it on broader theory using deductive reasoning. You can start with a general theory and use deductive reasoning to arrive at a more specific hypothesis. Or you can use inductive reasoning by looking at the results of many different specific studies and linking those in a way that is coming up with a more general hypothesis for you to test in your study. Hypotheses should not be value judgments. They can't be abstract phenomena that just simply can't be observed. They have to be testable. So for example, if I'm interested in understanding how the emotions of sports fans in a stadium affect the emotions and performances of the players on the playing field, I can't just say something really broad and abstract like, I think the audience's emotion affects the emotion of the players. It's just too abstract. It can't be tested. You need to put it in you need to sort of reword it in a way that's testable. These are the steps in the research process in my own words. So I have 6 steps, and I want you to start to get familiar with these 6 steps because this is basically how our course is sequenced. You'll notice these are listed in the syllabus. We basically go through these steps one by one, dedicating a few class sessions to each step, sometimes a couple weeks to each step. And we're going to start right away with choosing a topic and then move into how to write your review of literature. And that's something that you'll then be working on throughout the rest of the semester, is writing your review of literature. And while you're working on that, we're going to learn more about the later steps in the process. So how to design a study, how to make decisions about research design, participants, variables, and how to measure them, and deciding how you're going to analyze your data. And we'll also talk about research ethics, because getting ethical board approval is a crucial step that you're going to have to take before you start collecting data. We'll talk about methods of collecting data and analyzing data, and we'll talk about how to report findings either in writing or as oral presentations. But again, I just kind of want you to learn these steps and familiarize with them. There are a number of different academic skills used across the steps of the research process. So, thinking about sort of the writing, reading, and arithmetic of research. And I also added a couple other ones with writing, reading, numeracy instead of math or arithmetic, basically the same thing. Info technology, so using computers and new technology in your research. And also speaking, not just writing, but also speaking about your research. And so you can look at this and see like at what point in the process each of these skills is important. One of the things you'll notice is I have all of them checked for collect data, but really that depends on what you're doing for your study, how you're collecting your data. It may or may not involve some of these skills as much as others. But writing is definitely one that is important throughout the 6 steps of the process. So that just kind of gives further justification for why we emphasize writing so much in this course as well. I want you to be aware that research does have its limitations. So certainly, if we use the scientific method and we have a good research design, that's important at giving credibility and validity to our findings, but research is always going to have its limitations. It's going to have some limitations right away just based on how it's planned. It's also going to have limitations that are unpredictable and arise over the course of the study. But the point I want to make here is that in research we don't actually prove anything in a really concrete and solid way. There's always some uncertainty. So I want you to get away from using language like, Smith proved that blah, blah, blah. Instead, you'll say something like, Smith's findings gave evidence to support his hypothesis. And that's with a certain degree of certainty or uncertainty. So, like I said in the previous video, one of the things I want you to get out of this course is being able to identify the limitations of a research study and basically be able to criticize it, be able to say what was good about the study and what wasn't as good about the study. Ari et al., 2014, in their article, they talked about the challenges that are unique to social science that aren't as prevalent in, for example, like biology and chemistry and physics, where you have more certainly challenging disciplines, but doesn't have the same complexities that working with people has. So some of the challenges that they listed, a complexity of the subject matter. So again, just working with human subjects. The human brain, for example, isn't as well understood as a lot of other things, and also just understanding how people's experiences and genetics affect what they do and their health and their mental health isn't well understood. So there's the complexity of people, difficulties in observation. So tying in with what I just said, it's not always possible to directly observe things in social science. Often we're interested in knowing what's going on in the person's mind. So you can't observe that directly. You have to get them to talk to you about it, or fill out a questionnaire to answer questions about it. Difficulties in replication. It's often really difficult, if not impossible, to perfectly replicate the conditions of a study. And that's fine. We don't always just want to replicate studies exactly, but when we do, it can be difficult to do even if we wanted to. Interaction of the observer and subjects. A lot of times when we observe people and they know they're being observed, they act differently. And that was true of a study I participated in this summer, where I was asked to wear a sensor on my leg that basically detected whether I was lying down, sitting, standing, or moving. And as you can imagine, just knowing that I had this sensor on me and it could detect these things made me actually think about what I was doing, and probably made me a little bit more physically active than I would be just in my everyday life. Difficulties in control. Just as an example, if you have people coming in to participate in your study, like, it's not always possible to tell them exactly what to eat that day, or things like that could affect their outcomes. So things like diet, hydration, physical activity, other behaviors, smoking, etc. Sometimes you can tell them to do something or not do something, but that doesn't mean that they'll listen to you. Problems in measurement kind of ties in with difficulties in observation. We often try to measure things using a questionnaire to measure something indirectly, which is a lot more problematic than just measuring like a physical quantity, like a height or a weight or a temperature or something like that. So lots of reasons why research has its limitations, and in particular, research in social science. And that's all for this video. Thanks, and I'll see you next time.